Today's lesson is on the volume of triangular prisms and covers pages 46 to 47. So, because we're dealing with triangular prisms, we'll start by looking at a triangle. So the first question asks, what fraction of the rectangle is shaded? 1/2 of this rectangle is shaded because the shaded and unshaded parts are the same size. What is the area of the rectangle in square units? Because there are 4 squares, there are 4 square units. So you could just write 4 units. Now, what is the area of the shaded part? If the whole rectangle is 4, but the triangle is half of that, how many square units would it be? It would be 2 units. So then if we look through, what fraction of the volume of a rectangular prism below is the volume of the triangular prism? So if we were to look at a rectangular prism and we were to get a triangular prism out of it, we're essentially cutting it into how many pieces? Because we're essentially cutting it in half, it would be half of the volume. So what would you divide the volume of each rectangular prism by to find the volume? You would divide it by 2. So in order to calculate the area of a rectangular prism, we need to calculate length times width times height. So for this first rectangle, what 3 numbers would we multiply? You'd multiply 1 times 2 times 4, and that would give us 8 units cubed. Then to figure out the volume of the triangular prism, we simply need to cut that in half. So it would become 4 units cubed. So what we can remember is the volume of a triangle is going to be length times width times height, and then we will divide that whole thing, once we've multiplied it, divide it by 2. This is the formula we're going to use for the rest of our activities. Now, when we are dealing with certain triangles, you have to remember the height is not necessarily the side length. So if you have a right triangle and then you have it going out into a pyramid, this straight up and down here, because it makes a right angle, would be your height. So it doesn't matter, this could be width and this could be length, but this one has to be the height. Now, if we were to deal with a triangle that is not a right triangle, and it were to expand into a pyramid, we would have our length of the whole thing. Our width is going to be this whole space going across the bottom, but our height is going to be a perpendicular line from the tallest point to the lowest. So this imaginary dotted line here is your height. So you have to be very careful about calculating your height for this one. Okay? And so once again, we'll do length times width times height and divide the whole thing by 2.